Hello everyone, welcome to this video. In this video, we will be solving engineering mathematics questions which were asked in GATE 2022 paper of aerospace engineering. As we can see in this slide, there were total 11 questions asked in this paper, out of which 4 questions were asked for 1 mark and remaining 7 questions were asked for 2 marks. So let's try to solve these questions one by one. Coming towards first question. Yeah, here they have given us the curve y is equal to x square, and they are expecting the equation of straight line which represents tangent to this curve at point 1, 1. So the curve will look something like this. This is x-axis and this is y-axis. Let's say this is the point 1, 1. And at this point, let's say this is the tangent. And we are supposed to calculate the equation of this tangent. So we know the curve equation is y is equal to x square. And if we differentiate this equation with respect to x, we'll end up with the 2x. And dy by dx is nothing but a slope of this curve. And if we calculate this at point 1, 1, we will get 2. It means the slope of the line or slope of the tangent at point 1, 1 is 2. Equation of line we know is represented by formula y minus y1 is equal to m times x into x1, where x1, y1 are the points through which the line is passing and m is the slope of that line. So as we know all these things, we can directly say y minus 1 is equal to 2 times x minus 1 is the equation of tangent. So as we can see, option C is correct in this case. Coming towards next question. This question is from the vectors topic. Here I, j, k are the unit vectors given along x, y, z direction. So let's say this x direction, this is y direction. Suppose the direction is perpendicular to this plane of paper pointing upwards. If the vector I plus j is rotated about k by 135 degrees, one gets, and they have given us the 4 options. So we know, let's say this is I and this is j. If we rotate this I and j, so first of all, we'll calculate I plus j. I plus j vector would be like this. Okay. This is I plus j vector, and whose magnitude would be root 2. Okay. Magnitude of this vector would be root 2, because we can say, let's say this is 1 point, this is also 1 point, and this point would be 1, 1. So under root of 1 square plus 1 square is root 2 is the magnitude of this vector. So we can say root 2. So this vector is represented by root 2 I plus j. Okay. And as z direction is perpendicular to the plane of the paper pointing upwards, and that is a positive k. And if you rotate along that, okay, if you rotate about that, then this is how we will get the rotation. This angle is 45 degree. So as we are rotating in by 135 degree, we will end up with a vector which will look like this. Okay, so this vector will be along the negative x direction. So it is in terms of I, and we can see only 2 options are there, option A and D, out of which option D is correct, because magnitude of this vector is root 2, and if we rotate it by 135, we'll get minus root 2y. Okay, coming towards next question. This question is related to the complex numbers. Let x be a real number and I is represented by under root of -1, then real part of cos of ix is. Okay. So in general, cos of x is denoted by e to the power ix plus e to the power minus ix divided by 2. Because e to the power ix is means cos of x plus I sin of x, and e to the power minus ix is cos of x minus I sin x. So I sin x terms will get cancelled and we'll end up with the 2 cos x divided by 2. 2 will get cancelled and we will get cos of x. So, but they are asking us cos of ix. So here if you write cos of ix here into this equation, x has to be replaced with ix now. So it is e to the power I times ix plus e to the power minus I times ix divided by 2. Okay. And if you further solve it, you'll get e to the power x minus x plus e to the power x divided by 2, because I square is -1 and here minus minus will become plus. So, and we know what is this, e to the power x plus e to the power minus x divided by 2 is nothing but the cos of hyperbolic of x. So we can say that the real part of this is cos of hyperbolic of x. So option B is correct in this case. Coming towards next question. This question is again from the vectors topic. If a bar, b bar and c bar are mutually perpendicular vectors, then a bar dot b bar cross c bar can take values. Okay, so let's take it again. Okay, so let's say for example, a bar, b bar and c bar is like this. Okay, they are mutually perpendicular to each other. Whenever we calculate a cross product, we know all of them are unit vectors. So b bar cross c bar can be written as mod of b into mod of c into cos of theta. Sorry, into the sine of theta. So ultimately both the vectors are unit vectors, and so their magnitude is also 1 and angle between them is 90 degrees. So sine of theta will be 1. So what we'll get is the perpendicular vector to this both b bar cross c bar. So if we take a cross product of this unit vector in b bar direction and c bar direction, we will get a unit vector which is perpendicular to this plane, BC plane. So it will be either along a bar in the positive direction or negative direction. So you may get so to make it simple, I will just make it this as a b bar and this is c bar. So b bar cross c bar, if we take, we will get a vector which is perpendicular to this plane BC bar. It will be either perpendicular, it will be either coming outward or going inwards depending on the values of BC. Okay, so considering that, we can say in this case option B and C are correct, because it is the magnitude of that cross vector will be 1. Let me just show you here. B bar cross C bar is mod B into mod C into sine of theta. Okay, so we can get the mod values of this is 1 and 1. So it is the magnitude of that will be 1. Okay. Also by taking cross product also we can find I, J, K, dou by dou x, dou by dou y, dou by yeah, directly we should do it. The B bar would be, let's say, I B bar would be 1 0 0, and let's say C bar is 0, 1, 0. Okay, and now if we take um, the determinant of it, we will end up with a 1 K bar. K bar is a vector which is unit vector which is perpendicular to this, and we can say magnitude is again 1 here. So either we'll get it in positive direction or the negative direction, uh, depending on the direction of B bar and C bar. Okay, if B bar is a negative, let's say if we take a B bar in this direction, in that case also B and C are perpendicular to each other. Okay, so the possible, so we will have this as a -1, and we may end up with a minus K bar. Okay, so the possible answers are 1 and -1 in this case. Coming towards next question. This question is from the calculus topic. They are asking us to calculate the arc length of a parametric curve. We know the arc length of any curve whenever we deal with the two variables x and y, but here a third variable is added, which is z. So formula will not change much. So generally the formula, let's say if you have x is equal to f of t and y is equal to g of t. So what we do is we'll use t1 to t2 under root of dx by dt whole square plus dy by dt whole square. So this is the formula which we use in 2 dimension. Okay, now as it is 3D question, we have one more term here, dz by dt. Okay, and here rather than t we are using theta. So in general we can say the equation of arc of length is given by integration theta 1 to theta 2, and they have given theta is varying from 0 to 2 pi, so it is 0 to 2 pi under root of dx by d theta whole square plus dy by d theta whole square plus dz by d theta whole square. So in this question, the derivative of x with respect to theta is cos of minus sine of theta. Square of it is sine of theta, sine square theta. So basically sine square theta plus derivative of y is cos theta, square is cos square theta. Derivative of z with respect to theta is 1. And we also know sine square theta plus cos square theta is 1. So 1 plus 1 is 2. So under root 2 we will get here. Okay. And we have to integrate with respect to d theta. So root 2 and integration, root 2 is constant, we can take it outside. Integration with respect to d theta is theta, and limit is varying from 0 to 2 pi. So we'll get 2 pi. So if you solve it, you will end up with 8.89. So as we are supposed to round off till one decimal place, it is 8.9. Okay, approximately. So if you try to plot it in 3-dimensional, it will look like this. Okay. Yeah. Coming towards next question. This question is regarding the maxima and minima topic. Yeah. So let's try to solve it. So they are asking the height of a right circular cone of a maximum volume that can be enclosed within a hollow sphere of radius r. So let's try to draw the figure. Suppose we have the sphere and we got a cone here, right circular cone like this. Okay. Yeah. So let's try to draw the things. So let's say this is a center O, And from here to here, the radius is r. We can draw here this as well as r. This is BC points, and this is A point. Let's take this point as M. Okay. Yep. Suppose r is the radius of this cone, and take h is the height of the cone. Okay. So these are the dimensions. Now coming towards the solution part. So in this case, what we'll get is we have a triangle BOM. In considering this triangle, there is a chance that we will get a relationship between radius of the sphere and the radius of this cone. So out of that, we know r, small r, we know capital R, but we don't know OM. So OM can be calculated by height of the cone minus radius of the cone, radius of the sphere. Okay, small r is the radius of the sphere and h is the height of the cone. And now in triangle BOM, we can say by Pythagoras theorem, r square can be written as capital R square plus OM square, which is h minus r whole square. And if you further solve it, it is r square plus h square plus r square minus 2hr. And this is r square in the left hand side. This will get cancelled out, and we can say that r square is equal to, now 2RH, or 2RH minus h square. Okay, so let's keep it aside. We'll call it as equation number 1 or something. And now coming towards question. So this is a relationship between radius of cone and radius of you can say the sphere. But coming towards question, they're asking you the maximum volume of cone. So I'll go to the next slide. Volume of cone is given by 1/3 pi r square h. Okay, and now here we can put the value of r, which we have just calculated, and we'll end up with 1/3 pi h into 2RH minus h square. This h will go inside and we'll get pi by 3. 2r square, 2r h square minus h cube. This is the volume. Okay. If we differentiate this volume with respect to height and equate it to 0, we'll end up with pi by 3 is a constant term. 4RH is minus 3h square equal to 0. And we can say now 4RH is equal to 3h square, and we'll end up with h is equal to 4r by 3. Okay, so at h is equal to 4r by 3, either we'll have some maxima or some minima. Okay, this is also one of the option, but just before concluding it, we should check whether we are actually getting minima or maxima here. So if we differentiate this d2v by dh square, okay, and it will be like pi by 3, 4r minus 6h. Okay, and now if you put the value of h as 4r by 3, so it is 6 into h is 4r by 3. Ultimately, we'll end up with 4r minus 8r. Okay, so we'll get a negative answer, which is minus 4r pi by 3, which is less than 0. Hence, it is a maxima. Okay, so we can now conclude that 4r by 3 is the correct answer in this case. Coming towards next slide. Next question. This question is from the differential equation. They have given us the homogeneous differential equation. Let's take it. D square minus 2d plus 1 times y equal to 0 is the differential equation in the simplified form. And if we calculate the CF for this, it is d minus 1 whole square equal to 0, and d will be equal to 1 comma 1. So the solution of this equation would be CF itself, and it is C1 e to the power x plus C2x e to the power x. Let's call it as equation number 1. They have given us the initial conditions also, boundary conditions. At x is equal to 0, y is equal to 0. So we can put into equation 1, we'll get 0 equal to C1 plus 0. So C1 is 0. Okay, so this part will go. They have also given another condition, dy by dx equal to 1. So let's differentiate it. Dy by dx would be now, we will just consider the second part because C1 is 0. We have to ignore it. C2 times e to the power x plus x e to the power x. Now, if you put the another condition at x is equal to 0, dy by dx is 1, what we get is 1 equal to C2 times e to the power 0 plus 0. E to the power 0 means 1, so C2 is equal to 1 we'll get. And now we can put it into the equation 1, and we can say y is equal to x e to the power x is the final solution of this differential equation. But what they're asking the value of y at x is equal to 1 by 2. So if you put x is equal to 1 by 2, what we'll get? E to the power 1 by 2 divided by 2. E to the power 1 by 2 can be written as root 2 by root of e by 2. Okay, so hence option C is correct in this case. Coming towards next question. This question is from the partial differential equations. They have given us the partial differential equation dou 2f by dou x square plus dou 2f by dou y square equal to 0. Okay, where x and y are the real. If f of x comma y is a of x into b of x, and a of x and b of y, sorry, where a of x and b of y are real functions, then which one of the following statement can be true? Okay, just by looking into the differential equation which they have given, this is a Laplace equation. Okay, dou 2f by dou x square. Okay, plus dou 2f by dou y square equal to 0 is a Laplace equation. And so out of the given options, we have to think what could be the value of a of x and b of x which will satisfy this. Okay, so let's try to solve it. Whenever we say any functions which satisfies the Laplace equation, we will say it as a harmonic function. Okay, so it means it's the two derivatives of that function should exist, and if we differentiate it with x first and then y first, we'll get same value with just opposite sign, and hence those will cancel out each other. So if we take a linear function will have just one derivative. Second derivative will not exist for linear function. So all the options with a linear derivative will get can be ignored. So here we can say we can ignore option A. Coming towards option B, both are exponential function. So let's take a simple example. If we have e to the power x and e to the power y are, let's say, a of x and b of y respectively. And if you differentiate with respect to x, you will get the same value. If you differentiate with respect to y, you will get the same value. If you differentiate 2 times with x and y, will get the same. So here the negative term is not coming. So ultimately, we can say that both a of x and b of x are, if we take as exponential, in that case, we may not end up with the function which satisfies the Laplace equation. Okay. But now if we take a third option where a of x is periodic, let's say sine of x, and the b of y is exponential function e to the power of y. And now if we take a derivative of this function 2 times, so if we differentiate sine of x 2 times, what we'll get? We'll get minus sine of x e to the power of y. Okay, and if we differentiate this function, overall function, with respect to y, we'll get same function, because e to the power y differentiation 2 times is e to the power y. So now you will get here, if we have one periodic function, after 2 derivatives, its sign will change. Okay, and that's why option C is correct in this case. Okay, if we take 2 periodic function, what will happen? After 2 derivatives, sign of each periodic function will change, but that will cancel out with each other, and ultimately you will end up with the same function value. So you won't be getting a function which will satisfy the Laplace equation. Hence option D is also wrong in this case. Correct option is option C. Okay, so just to make it clear, I will write it here. So this is, let's say, this is our f of x comma y, and differentiation of f with respect to x, double differentiation is minus sine of x e to the power y. Differentiation of this function with respect to y 2 times is e to the power y sine of x as it is. And if we add them, it will cancel out with each other. Okay, that's why we considered option C as correct. Coming towards next question. This question is again from the calculus topic, continuity and differentiability. They have given a function y is equal to sine square mod of x, and they're asking whether it's a continuous, differentiable, not continuous, not differentiable. And we know that all mod functions are continuous everywhere. Okay, mod functions are continuous everywhere. So first of all, option A is correct. Okay, and mod functions are not differentiable wherever it becomes 0. Okay, but here we got a square function. Okay, it's a sine square mod of x. So if you look into the plots of this, the plot which is in red is for sine of mod x, and plot which is in blue color is sine square mod of x. When we say a function as a differentiable, the function is differentiable wherever we have unique tangent to the curve. Okay, and we can see that for a blue curve, we will have a unique tangent at point 0. Yeah, so at point 0, we will have unique tangent for a blue curve. But for red curve, we got a sharp end there. So whenever we got some sharp end like this, there is a possibility that there can be more than one tangents at that point. Okay, so we will say that will not have unique. So it means we don't have a unique derivative at that point, and it means that function is not that differentiable. But as they are asking us the square function, sine square mod of x, and looking into the curve, we can say that the function is differentiable for all values of x. So both option A and B are correct in this case. Okay, all differentiable functions are continuous. Okay, so that's also the reason why we are taking the option A. Coming towards the next question. This question is from the again vector calculus. Okay, coming towards this question, we can say that they are asking us to use Gauss divergence theorem. They are given V bar is equal to x cube I plus y cube j plus z cube k. Okay. And I, j, k are the vectors of Cartesian coordinate system. Using Gauss divergence theorem, the value of outward flux of vector field over the surface of a sphere of unit radius centered at origin is. Okay. So what is the surface of sphere of unit radius? Sphere of unit radius, we can say the equation for that should be x square plus y square plus z square equal to 1. Okay, so let's coming towards this v bar. So they are asking us to use the Gauss divergence theorem. So according to Gauss divergence theorem, we can say integration over a surface. Okay, the bar cross n bar can be written as let's f bar dot n cap ds can be written as triple integration or integration over a volume divergence of v, okay, into dp. Okay, so let's consider this volumetric integral and this as a surface integral to make it simpler. Okay, now we have to calculate the divergence of v bar first. So v bar is given, so divergence of v bar would be dou by dou x I plus dou by dou y j plus dou by dou z k operating on x cube I plus y cube j plus z cube k. So ultimately what we'll get is 3x square plus 3y square plus 3z square. Okay, so it is 3 times x square plus y square plus z square. And we know x square plus y square plus z square is nothing but 1. Okay, because according to the equation of sphere, in this case, it can be written as 1. So now coming towards the volume integral, integration over a volume, 3 times x square plus y square plus z square dv is what we have to solve in order to get the answer. X square plus y square plus z square is 1. So 3 times dv we will get, okay, and integration of dv is v, and we know the enclosed volume will be the volume of the sphere because surface is of sphere, so enclosed volume will be again volume of the sphere, so it will be 3 times as it is volume of the sphere is 4 by 3 pi r cube, 4 by 3 pi r cube. Radius of sphere is given as 1. So it is 1 cube is 1, 3 will get cancelled. So ultimately we'll get a answer 4 pi. Okay, so final answer in this case is 4 pi, which is 12.566. And as they are asking us to round off to 1 decimal places, we can say it as 12.6. Okay. Coming towards the next question, this question is from linear algebra. Here they are asking us to calculate the largest eigenvalue of a matrix. So let us consider this matrix as matrix A. So A minus lambda I would be the characteristics vector, and if we take a determinant and equate it to 0, we'll get a characteristics equation out of it. And directly we can write it as 0 minus lambda, which is minus lambda 1 1 0, sorry, 1 minus lambda 1 1 1 minus lambda. And now if we take a determinant and equate it to 0, we will end up with the characteristics equation, and it will be minus lambda into lambda square minus 1 into minus lambda minus 1 plus 1 into 1 minus lambda. So it is minus lambda cube plus lambda. Okay, here I think it should be plus lambda. Yeah, minus lambda cube plus lambda plus 1 plus 1 plus lambda. So it is minus lambda cube plus 3 lambda plus 2 equal to 0. Okay, so if we solve this equation, if you put lambda is equal to 1, what will happen? Minus 1 cube is 1 plus minus 1 cube is minus 1. So minus 1 plus 3 plus 2, you'll end up with a 0. So one of the eigenvalue is minus 1 in this case. Okay, because yeah, if you put minus 1, what will happen? Minus 1 cube is minus 1. Plus 3 times minus 1 plus 2 equal to 0. So minus 1 cube is minus 1, minus minus will become plus 1. So 1 plus 3 plus 1 minus 3 plus 2 equal to 0. So one of the eigenvalue for this is lambda is equal to minus 1. So if we divide this equation, which is minus lambda cube plus 3 lambda plus 2 with lambda plus 1 as a factor, we will get another quadratic equation, and that will give us the two more eigenvalues, lambda equal to 2 and minus 1. So the three values of three eigenvalues for this are 2, minus 1, minus 1. And out of this, the maximum value is 2. Hence, the largest eigenvalue of the matrix is 2. Okay. So, or else we can just put this 2 here into this equation and check whether it satisfies or not. So 2 cube is 8. So minus 8 plus 3 times 2 is 6 plus 2. 6 plus 2 is 8. Minus 8 plus 8 will get cancelled. So 2 is again the eigenvalue. And that is the maximum eigenvalue in this case. Okay. Yeah. So that's all from this 2022 paper. Thank you all for watching this video.